everyone. We are the Group 5. Today, we will be presenting a report about plane mirrors. We know that these mirrors are the ones we encounter in our daily lives, like the one in our room, bathroom, or dressing room. In this report, we will explain how plane mirrors work. So let's get started. A plane mirror works by reflecting light. When light hit the mirror surface, it bounces back. These reflections follow a rule called the law of reflection, which say that the angle the light comes in at is equal to the angle it bounces off at. And when we look at ourselves in plane mirror, we see a reflection. This reflection is like a picture of us, but it is real picture that we can touch. The reflection appears to be the same distance behind the mirror as we are in front of it. Also, the reflection is the same size, but it switches our left and right side. So how does this happen?
So, plane mirrors. Plane mirrors are perhaps the most common type of mirrors around. When you shine a flashlight on a flat mirror, the light bounces off. When you look into it, you see your image. So how does this happen? So to answer this question, we will use our dot as our object, this one. So it is a distance d in front of the mirror. So light rays from source bounce off dot to the mirror. So the objects bounces off the mirror. So the light rays that reach the mirror from the objects are the incident rays, which are this one. So of all the infinite numbers of incident rays, we will pick two. We call them ray 1 and ray 2. So I'll just provide the first one, which is ray 1. Now let's move on to the second incident ray, which is the ray 2. So draw the second incident ray, the ray 2, from the object toward the mirror, such as that is normal to the mirror at the point labeled as the point B. So it is drawn like this: object to mirror, then we call it point B. Okay, so the angle of incidence of ray 2 is 0 degrees. Then because it is right at a Roman line, this means that the reflected use of ray 2 goes straight back toward the objects. It doesn't reach the eye, so the observers does not see the reflected ray. So the objects on the point of the B is just bounce back on the object, so the eye does not see the object. The last example, the two reflected rays intersect at a point behind the mirror exactly the same distance as the object. So the intersection of rays is what gives us an image. The eye has no problem seeing an image. However, this is because the eye automatically extends the reflected rays straight back behind the mirror. The two rays intersect at a point exactly the same distance as the object. This is where the image appears to be a distance behind the mirror. So what I said, I'll explain it. It is like this. So we see two triangles, the one from the object to point A and B, and the one from the image to point A and B. These two triangles are similar, therefore the sides are congruent. Thus, for a plane mirror, the object distance in front of the mirror is equal to the image distance behind the mirror. In symbols, it is, by convention, we represent any distance behind the mirror as negative. So in short example, the object, is just the same on the other side, but the eye can see the image because it is reflected by the light. So this is just a virtual image. Okay.
So how do we create the mirror image of an arrow? To create this, we actually use all the three previous steps we learned earlier and combine them to create the image. The only difference now is that this time we use a bigger and much larger object, unlike the three parts which is dots. So if we see here, this arrow indicates the object or example that we are using. This is its size. We have here the bottom and its top. So by following the step 1, the arrow which leads our eyesight bounces here, going to the bottom, looking here at the bottom. And just like in step 2, we see this invisible line which is a straight line. We don't see that because our eyesight goes downwards. So you might be wondering why there's two lines right here. This is actually because we are looking at the bottom and the top of the object or example. So here at the step 3 which we explained earlier, we'll know that any arrow that goes at the back of the mirror is called an image. So this is that image that we created. So every time the direction of our eyesight changes, all of the arrows actually rearranges themselves at a certain point. So by looking at its bottom and its top, we get to make a mirror image of an arrow. So this is what we made from looking at the bottom here and the top of the object.
Characteristic for plane mirrors. Plane mirrors image all possess the following characteristics. First, they are located behind the mirror. Such an image is described as a virtual image. A virtual image is an upright image that is achieved with the rays seem to diverge. It is produced with the help of a diverging lens or a convex mirror, and it is also found by tracing real rays that emerge from an optical device backwards to perceive apparent origins of ray divergence. They are unmagnified. This means that the image is always the same size as the object. For example, when you look in the mirror, your image is the same height as you. Why was the image formed by plane mirrors are called virtual image? Well, plane mirror image are illusions. They aren't actually behind the mirror. What is behind the mirror is called the wall. It could be a cabinet full of clothes or another room. The image is in observer's brain. That's why it is called a virtual image. They are upright or erect. A plane mirror forms images that are oriented the same as the objects. Another characteristic of mirror image. It is called perverted. For example, if you attempt to shake hands with it or in the front of the mirror, the image will use what would be its left hand, which is actually the image of your right hand. Also, if you're wearing a shirt with print on it, the image of the print is reversed. This is the example of characteristic of perverted, or in short, perverted image is flipped from left to right.